we're going to start section 2, which talks about acid strength. And so we're going to start off, first of all, talking about just strong acids in general. And so what makes a strong acid? First of all, of course, it has to start with an H, but also, in order for it to be a strong acid, it has to completely dissociate in a solution. And so there are only actually 6 acids that completely dissociate in solution. And so these are the 6 acids that completely dissociate: nitric acid, hydrochloric acid, sulfuric acid, perchloric acid, hydrobromic acid, and hydroiodic acid. So these are ones that you're going to have to, know, learn, memorize, get to know these guys. These are important. These acids, when you put them in a solution of water, they will completely break down into ions. There will be no acid left over. So that's what classifies them as strong acids. Versus all the other acids, which we classify as weak acids, these guys only dissociate to a small extent. So like if I give you an example of acetic acid, HC2H3O2. It breaks down into hydrogen ions and C2H3O2 when you put it in water. So that acetic acid, it actually, instead of like a typical strong acid, strong acids like push all the way over here. They go all the way into ions. There's none of this side usually left over. Well, for a weak acid, you actually still have quite a bit of this left over. It doesn't push all the way over here. And so that's what makes it a weak acid. Well, how do you know you have weak acids? They're not strong, meaning they're not one of those 6. So if they don't fall in one of those 6, then you know you have a weak acid. And so that's why it's important for you to learn and memorize that list of 6 strong acids. Now, we have these things called diprotic and triprotic acids. Just another way to classify acids. A diprotic acid is one that has 2 protons. And so what does that mean? Remember, proton stands for H+, and so that means it's going to donate 2 hydrogen ions. So look at H2SO4. Notice how it has 2, maybe if I can, there we go, H2. So it's 2 hydrogens that it can donate to the solution. A triprotic acid can donate 3 protons to the solution. And so notice H3PO4 can donate 3. Now, the thing is, too, though, they can donate 3 protons or 2 protons, but they don't just donate all 3 at once or all 2 at once. What they do is they actually donate 1 at a time. So notice the dissociation down here of carbonic acid, HC2H3O2. So what they do is they actually donate 1. So notice that it donates its 1 hydrogen, and then it gets an ion, HCO3. And then what it'll do is then it'll come down here in a new reaction, and then it'll pop off another hydrogen, and then it'll get its final product where it has no hydrogen left over. So it does this in a 1-2-step process. And so if it was a triprotic acid, this would be a 3-step process because they would need 3 steps to remove all of the hydrogens. We also have these things called oxy acids. Oxy acids are where what's considered the acidic hydrogen, the hydrogen that gives it its acid properties, is attached to the oxygen atom. So like, for example, phosphoric acid is actually considered an oxy acid. And so if we were to draw the actual Lewis structure out for phosphoric acid, when you draw it out, you have your P, and then you have your O, and attached to the O would actually be an H. And I know this is not the full Lewis structure, I'm just kind of drawing part of it. But here would be the outside layer of it. You would have a P, an O, and an H. And so that would be the oxy acid of it. Notice that the O and the H are attached. And so that's where we get the name oxy acid. We also have these things called organic acids, and this is where you have like a carbon backbone, where you have, like, you could have lots of carbons, a couple carbons, it just depends on what you have. And so you have, you know, a group of carbons, and attached to it you have, maybe off of the carbon, you have an O, and an H. And so this OOH, or even sometimes even we call it the COOH, that's called an organic acid, or we call that a carboxylic acid group, or a carboxyl group. And that's kind of a key component in something that we talked about a little earlier called acetic acid. And so that's why sometimes if you look up acetic acid, you can write it two ways. I call it the inorganic way and the organic way. So we've written it the organic way all year long, where we write it HC2H3O2, or you can write it using that carboxyl group right here. So it's just another way of writing it down, so you have that COOH. So those are just some other ways of classifying acids, where you call it an oxy acid where it has an OH group, or an organic acid where it has that COOH group. Some other things about acids and their relationships. If you have a strong acid, okay, so if you have that strong acid, so you have one of those that were on your list that we talked about it before, then you're definitely going to have a weak conjugate base. If you have and we didn't talk a lot about strong bases, but we do need to talk about this in terms of conjugate acids. If you have a strong base, then the result is going to be a weak conjugate acid. And then kind of the opposite. If you have a weak acid, you're going to have a strong conjugate base, and a weak base, you have a strong conjugate acid. So those are just some relationships there to kind of go along with what we talked about in the last section with conjugate acid, conjugate base stuff. So this will kind of set you up, and this is more information stuff that you'll have to know for, you know, your quizzes and tests.